Hi everyone, this is John Wen. Today is January 13th, 2020. Hopefully you have enjoyed a great break since the Christmas, as well as you have fulfilled the energy and be refreshed since the new semester kicked out. So hopefully this will be a good start of this year. And in today's video, I'm going to go through the research updates in the past weeks. So as you can see, I keep working on the deep learning workflow, but before that, I hope to give you a highlight of the DataView 2.2, since I'm working on to give a tutorial of the DataView 2.2 and work with a cloud service. But while I working on it, I noticed that there's some issue prevents me to run the DataView 2.2 successfully on the cloud service because of the image in the AWS of DataView may be obsolete and we need to make some new image. So Bai helped me to investigate and debug the issues, and I will keep working with him to get it fixed, maybe in coming weekends or coming week. So get back to the deep learning workflow, and here is a highlights what we're supposed to do in the previous work. So here is a structure of the reusable deep learning workflow, which is going to be a kind of learning or training process as well as a reusing process. So here is a part of the training, and we are going to save the weights and bias into somewhere, maybe in a file, and then whenever we need this model, we are able to reload this model from this file and reconstruct a new network with any new data input. So here is a implementation plan, and the previous work we are able to print out the weights and bias, and further we can save that into the file in the data view. And for the past weeks I was working on to reconstruct the model, and I was able to successfully reconstruct the model with any input weights and bias. So maybe I can show you the code. This will be more straightforward. So this is a new code I was working on. So before that, I was able to print out the weights as well as bias after the training process, and we also can predict the new score with the new data. So that is a routine of the training process, and what we need to do is we want to reconstruct the model with the data we saved, for example like the weights and bias. So here is what I did. I add a new vector of vector as weights and then put them into a hash map, and also the bias we do the same thing. And not only we are going to input the new network structure, we also input with a weights and bias hash map. So here is a code. We're going to comment the training process. So I believe this part is going to be the training process. So we are going to comment this out, and we are going to load the model directly with weight and bias. So that's what we are going to construct the new network. So this is different from previously, because previously we only take the structure, for example like how many input neurons, how many output neurons we want for each layer. But here we also input the weights and bias. And also after we load we construct the new network, we skip the training process, we go directly to print out the layers, and then we go directly to compute the accuracy of this reconstructed neural network with data we have in this program. Maybe in the future we can load the input data from DataView, so we can reuse the model at any time we want. So here is a outline of this program. So you can see the weights and bias is just purely randomized. I just put some random numbers here, so you can guess the result. The prediction score will be very low. So we can run this program, and you can see. So you can see we're going to load and construct the same layers we had before. For example, like linear layer, ReLU layer, and linear layer, and sigmoid layer. And what's more, when we construct the neural network, we are going to print out the weights. As you can see, the weights exactly same as we input, and bias is also same as what we input at here, and also the second linear layer is the same. And you can see the accuracy is 0.38, which is below 0.5, because this is a really bad initialization or really bad guess. Maybe you can think about a good guess is half, right? But here you can see the score is really low, so that's with our expectation. So I think that's a good progress, and we're able to reload the model. So this is a pure work in the CUDA, but I think that won't be too much work to extend in the data view. So after we, I think we can wrap something similar to previously. We can work with Eclipse and call that method from the Eclipse, and we can put that into a task, and we can streamline the workflow as we expected. So for the future work, maybe we can input the new data from the data view and input into the newly constructed neural network. So that's a future work, and we can predicting with the new data. And also, I'm going to work on to construct a new network with a convolution layer. So that's very important, because for the current deep learning workflows, many things we need convolutional layer as a basic requirements. So here is something we proposing before, and how to make something we can utilize reinforcement learning in our data view. So that's something we can do in the future. So I think that's pretty much for today's video, and hopefully you enjoy. And until next time, happy coding. Thank you for your time.